Here in two-dimensional viewing, what do we understand is we have our original image, okay, or original scene, whatever you call it. Okay, why should I make it a rectangle? Let me make it like this. Okay, this is a scene that I want to display. Now it is in a particular coordinate system. Each and every pixel will have a coordinate value. So this is our scene that we want to display. However, there is something that we have to consider. We have an output device, usually rectangular. This is our output device. Now this output device can be bigger than this image, or maybe smaller than this image, maybe not of the same size. Even if it would be of the same size, doesn't matter. We have to understand one thing, that how to display your object, or let me call it an image, a picture, a scene, to your output device, on your output device. Okay. Now here, one more thing that we have to understand is, this was your whole picture that you want to display. Oh, wait a minute, really? Do you want to display the whole picture, or you want to display some small portion of this whole scene or whole picture? Let me start it again. This was your output device. On the output device, definitely you can display something. This output device will have some coordinate system and definitely coordinate values. In this output device also, it is not always the scene that you display your desired picture on the full screen mode. Okay, sometimes it may happen that you want to display on a smaller portion of your output device. Okay, let me name these two things. This is called a window. Okay, and this is called a viewport. Okay, here we are using the term window, but you have to understand that normally that you have seen windows, these things here in output devices or your operating systems. Okay, that is different. Window manager and those kind of things will be there. Let it be. Here the window is a portion of your picture to be displayed. Okay, so this is a window. This window specifies the portion of your scene or the portion of your picture to be displayed on the viewport. Okay, so now you have to understand that whatever there is inside this window should be displayed on this viewport. This is our job in two-dimensional viewing. Two-dimensional viewing means the picture is two-dimensional, viewport is two-dimensional, window is two-dimensional. Whatever it is there in the two-dimensional window, we have to display it here. While displaying, we may have to do some of the things, right? So what we may have to do, we may have to perform some operations. Maybe the size is not fitting, maybe the orientation is not as desired, or such kind of things may be there. So in that case you will have to perform some operations and make this portion of the picture visible on the viewport. This transformation will be called as viewing transformation. Let me write it here. It is called viewing transformation. Okay, this viewing transformation can also be considered as window to viewport. Window to viewport transformation. Okay, or you may also call it as windowing transformation. Okay, so what we have seen till now, we have understood that we may have a picture to be displayed. Okay, so it should be displayed on an output device. On an output device there will be a portion of the output device where we want to display, we will call it as viewport. And it may happen there will be a portion of the image, portion of the picture to be displayed, we will call it as window. This window can be smaller, can be bigger, that may depend. Okay, but whatever is there inside the window, it should be displayed on the viewport. So this transformation may be called as viewing transformation, or it may be called as windowing transformation or window to viewport transformation. Okay, so here now we have to understand that what is the pipeline of this kind of viewing transformation. Okay, so let me write it as viewing transformation pipeline. Viewing transformation pipeline. Pipeline means how do we, what are the steps involved in this viewing transformation. That is what we understand as viewing transformation pipeline. Okay, so till now do you have any confusion? What we have seen here is viewing transformation pipeline, which are the basically steps involved in transforming from window to viewport. We will construct the whole scene, construct the whole image using our basic primitives that we have learned, maybe point, line, polygon and others. And after that we will convert this whole coordinate to viewing coordinate, that this is the portion that we are going to view, and then we will map this viewing coordinate to the normalized viewing coordinate, which will be between 0, 1, and then you will map this normalized viewport to the device coordinates. Okay, now we will see in detail how these things are done. Before that let us confirm, have we understood this part?
So now actually
we were trying to understand how we are achieving this kind of normalized windows to viewport transformation. What is happening? Whatever we have the coordinate in our window, we have to transform it to viewport. So without doing it directly, what we need to do is trying to understand the ratio of the x and y coordinate with the size of window. So suppose it was xw, so size this xw upon the total x size. Okay, how do you get this total x size? This is xw max, this is xw min. So xw max minus xw min will give you this size. So the ratio of xw upon the total width should be equal to this ratio, the ratio of xv upon the width of this viewport, right? So since we understand that this should be equal, from this equation where we have written xw minus xw min, this portion upon the total width, this portion xv minus xv min upon the total width of viewport. From here we are trying to find out the value of xv, which is xv is equal to this is going here multiplication, so xv max minus xv min upon xw max minus xw min into xw minus xw min plus xv min, which was already here, right? So using such thing, what we are getting here, that we are getting xv and yv. This xv is the minimum xv plus whatever the distance was in xw into the scaling factor. This scaling factor is not just 1 or 2, 1.2 or something given by us. It is a normalized scaling factor, which we have got by having such kind of ratio, the ratio of width of viewport upon width of window. So using such thing, it gets normalized. And then similarly for y also, you will have the height of height of viewport upon height of window. Okay, so these are the two scaling factors here, and using this equation you will try to find out the transformation for converting the window area to the viewport area. Now this is not only the thing that you will need. Sometimes you may also need to rotate and translate these kind of things also. Okay, your viewport, whatever your window was there, from your window, if you have to transform it to viewport, you may have to rotate and translate as well. Rotate and translate. So such kind of things are also possible. One thing that here I should have said, one more thing, that here scaling is being done but this scaling is relative. Okay, so it is just kind of normalizing and taking the coordinates from windows to the viewport. Now if you want to resize it, or here what means the resizing is the zooming or zoom in or zoom out, that may also be possible, right? What can you understand about zoom in and zoom out? We will also have rotate and translate, that is we will see zoom in. What do you understand with zoom in? Can you tell me? Zoom in operation and zoom out operation. So for performing zoom in operation, what you need to do, you need to decrease the size of window. If you will decrease the size of window, the effect which will come here will on the viewport will look like a zoom in operation. If you want to perform successive zoom in operation, which means you will have to reduce the size of window successively. If you will increase the size of window, it will be a zoom out operation. Okay, you can successively zoom out, means successively increase the size of window, so that the whole picture will start coming in the same viewport. It will be zoom out operation. Okay, the only thing that we have to understand is whatever is there is in window, inside the window, is being displayed on the viewport. So if the window is bigger, that means a bigger picture is visible. Okay, and if window is smaller, then a smaller portion of the picture is visible on the same fixed size viewport. So if a smaller portion of the picture is visible on the same fixed size viewport, so it will be look enlarged, and on the same fixed size viewport, if a larger window is there, then a larger portion of the picture is being shown, so it will look like not enlarged, opposite of enlarged, right? So that is thing. Other than that, if you want to perform rotation and translation, sometimes it may be required. When suppose your viewport was I should say the coordinate systems of your viewport as well as your world coordinate system is not same. Okay, in that case you may need to perform some operation, like you may have to perform rotation and translation on the picture itself, so that it could be adjusted to the new coordinate system of the viewport. Okay, so we already understand how to perform rotation and translation. We have a rotation matrix and translation matrix, and we can get a composite matrix for rotation and translation. So that is not that big thing. Having known about these basics of viewing and the viewing pipeline, now we are ready to understand one thing, that how it can happen that you have decided a window and only a portion of this particular picture, the portion which has been decided by the window, will be displayed and the other rest portion will not be displayed. This thing will be considered as clipping. By using this window, you are clipping. Clipping means you are accepting whatever is inside the window and rejecting whatever is outside the window. Okay, so this operation will be called as clipping, and those algorithms which will support this clipping, we will call it clipping algorithms. And the next thing that we will see will be clipping algorithms. Please go through the book and try to understand. If you have any confusion, you can ask.